Sixth grade lesson 10.4 is explore area of trapezoids. And before we even start exploring the area of trapezoids, let me refresh your memory on what a trapezoid is. A trapezoid is a quadrilateral, quad meaning four, so a four-sided figure with one pair of parallel lines. So you look at this trapezoid, it has four sides, 1, 2, 3, 4, and it has this one pair of parallel lines. If these two lines went on and on forever, they would never intersect. These two would though, right? If they kept going, they would intersect at some point. So a trapezoid only has one pair of parallel lines, not two pairs like a parallelogram does. Here we have a trapezoid. There's its pair of parallel lines. And here we have a trapezoid. Here is its parallel lines. These ones would intersect at some point. I remember the word trapezoid by thinking, it's a triangle who had the top of it chopped off in a mouse trap. Mouse trap, trapezoid. Because this one would have been a triangle, but its top got chopped off. This one would have been a triangle, but its top got chopped off in a mouse trap. So this one would have been a triangle, but top got chopped off in a mouse trap. That's how I remember what a trapezoid is, or what the word for it is. It lost the top in a mouse trap. Vocabulary that's important to remember for trapezoids is these parallel lines we call base 1 and base 2. This one has it listed, this is base 1 and this is base 2, although if you reverse them it's not a big deal. And then you just need to know the height, going from a right angle to the top, from base 1 to base 2 at a right angle. That's where we would measure the height. So those are the pieces of information we would need to have. And you'll see base 1 and base 2 as we go further on this noted this way. Base 1, base 2. You'll see them written that way. And so now you know what those symbols mean. Let's have a look at exploring trapezoids so that we can find the area of a trapezoid, because we can't very well use the triangle formula and we can't very well use the parallelogram formula. So we're going to have to figure out what we can do here. All right, so here I have this trapezoid triangle that got its top chopped off on a mouse trap. It has a base 2 with 3 units, a base 1 with 6 units, and a height of 4 units. Let's say I traced that onto a piece of paper and cut it out so that I have a duplicate of it, and I place it side by side but upside down with this trapezoid. It would end up looking like this. So this one is the original one from here. And then this is the cutout one that I have flipped on its head and then put right next to it. And have a look at that. That shape now is a parallelogram. Parallel lines, four-sided. I have just made a parallelogram. So any trapezoid that I take its copy and flip it upside down and put it next to it, I am going to get a parallelogram. Good to know, because I know how to find the area of a parallelogram. And this trapezoid is exactly 1/2 of that parallelogram. So I would take the base and take a look at my base. It ends up being the 6 units from this original base, and then the 3 units from the second base. Base 1, base 2, right? Put together, 6 plus 3. So I now have for my parallelogram a base of 9 units. And I know for area of a parallelogram, I do base times height. Well, when I put those two together, I ended up with 9. Base 1 plus base 2. Then I take my height, which is 4. And the area of the parallelogram is 36. Now, I didn't want the area of the whole parallelogram. I really just want that. Remember, this is half of this whole thing. So I'm going to cut that in half, or divide by 2, and that will give me an area of 18. So in order to solve this area of this trapezoid, I just imagine that I take its twin, flip it on its head and put it right next to there, and now I have a parallelogram. I can solve for that parallelogram, and then I can cut that in half to find out the trapezoid's original area. All right, let's look at one more example just to see it. Here I have a trapezoid that has a base 1 of 9, a base 2 of 5, and a height of 3. Now, if I took this twin and flipped it over to the other side, it'll look like this. So now I have this rectangle, length times width, right, for the area. Base times height, same thing, right? So we'll just say area equals base times height, or length times width, since it's a rectangle. They are going to give me the same thing. My base of this whole rectangle is the 9 plus the 5 from the upside down part from over here. So for a total of 14 when I add those together. And my height is 3. So I just fill those in, 14 times 3, to get the area of the whole rectangle. That is 42. And then in order to get that back down to just being the trapezoid, I'm going to cut this in half because this was the area of the whole rectangle. I only wanted half of it, so we would divide by 2, and that gives us 21. Area of the trapezoid, 21 centimeters squared. Area is always in units squared. We're still in area. It was two-dimensional figure, a dimension times a dimension, so it's that dimension to the second power. So that's how you do this. For now, we're just going to go ahead and take our trapezoid, flip its match over, add the base 1 to the base 2. Then that gives us the whole base. Then we'll multiply it times the height, like we do for a rectangle or parallelogram. And then because we only really want half of that as the trapezoid, we'll cut it in half, and we'll have the answer. That's all we're doing for this lesson. Go give it a shot and see how that goes. And I'm sure you're going to do an amazing job.